So we're going to start on investigation 6 on page 526. We already know what the A value does to the graph. The A value is the amplitude. It's the height of the graph. We know that the B is the frequency, how many cycles we see in 2 pi. And we know from the frequency, we can get the period of the graph, which is 2 pi over B. So take a minute, work through the investigation with your calculator, and let's figure out what the C and the D do. All right, welcome back. So what you probably found is that C moves the graph left or right. It's the horizontal shift. And when the C value is positive, when the expression is x minus C, that's when it moves to the right C units. And when it's negative, or x plus C, that's when we move it to the left C units. And you also probably noticed that D is the vertical shift. So if the D value is positive, the graph goes up D units. If the D value is negative, it goes down D units. So let's see if we can put this in action and sketch a graph with all these different parameters, A, B, C, and D. So we're going to look at example 11 on page 527. And I'm going to kind of show you how I would sketch a graph like this. So a couple things about this graph to begin with. Let me just put some tick marks on my axes maybe so I get a feel of where everything is. Let's call that 2 pi. So half of that is pi. Half of that's going to be pi over 2. The other half is going to be maybe 3 pi over 2. So that's what our graph is going to look like. So a couple things we know. We know that our amplitude is 2. We know that our period is 3. I'm sorry, the frequency is 3. So then the period is 2 pi over 3. So what this is going to help us to figure out is that there's going to be 3 cycles of our graph in here. So I'm going to stop there for a minute and just kind of think about what that's going to look like. I know that my graph is going to go from positive 2 to negative 2. So this is what my domain and my range are going to be. So I'm almost thinking, I got to put my graph in this box for now. I'm going to shift it left and right and up and down in a minute. But I got to draw 3 cycles of a sine graph in here. So it's going to go something like this. Let's see, 3 cycles of it. So every cycle is 2 pi over 3. So here's where 2 pi over 3 is going to be. Then I'll go another 2 pi over 3 to like 4 pi over 3, which is about here. So I'm going to draw, let's see if I can draw 1, 2, 3 cycles of my graph. So basically, it's going to be this green graph. But now I got to do my shifts to it. So the thing that I noticed is that my C value is negative pi. So that means it's going to go to the left pi units. And the D value is negative 1. So it's going to go down 1 unit. So let's see, on my graph, pi is going to be right here in the middle. I don't think I can move that along with my graph. But what I'm going to do now is I'm going to see if I can slide this graph to the left pi and then down 1. So I've basically taken this point right here and moved that point left pi down 1. And doing that, move my whole graph over. So maybe now I just got to finish drawing some of my cycles. It looks like it's going to go up like that, down like that, up like that, maybe finish somewhere up there. Oh no! I want to go a little bit lower here. There we go. So that's my new graph. And I want to point something out about this graph now. Notice that the range has changed. That the amplitude is still 2, but the range now goes from -3 up to 1. So another way to express the amplitude, if you have a graph, is that it's the difference of those maximum and minimum values divided by 2. And another way to think about the value of D, if you will, the vertical shift. The vertical shift is going to be what the average of the maximum and the minimum is. Because, and I can slide this graph around a little bit, so bear with me. If I put this blue graph back to where it was, notice that the middle of the graph, the average of positive and -2 in this case, is 0. But if I want the average to be -1, I got to take my maximum and minimum values and add them together and divide by 2. That will come in handy in a little bit as well. So what I want to do now is I want to get into some really fun stuff with this. Because now that we know what a graph of that could look like, we want to do some modeling of the periodic functions. So I'm going to ask you to stop for a minute and take a look through investigation number 8. We're going to be doing this in class, and it's going to take us a while to do in class. So we're eventually going to pick up with eventually getting up to question 12 and 13 in this investigation. So I'll stop here, give it a shot. Hey, so welcome back. So after working through this function, this investigation, getting some of these values and creating a table of values and plotting a bunch of points, getting a periodic function of riding on this awesome Ferris wheel. Oh, great. What you should end up with in question number 12 is that they ask you for the amplitude, they ask you for the period and the vertical shift. So what you find is that because the height of the Ferris wheel is 120, you're either going up 60 above the middle or down 60. So the amplitude turns out to be 60. But because you get on 2 meters above the ground, your shift is actually a shift of 62. And your period, because you go around in 30 minutes, that's going to make your B value 2 pi over 30, or pi over 15. So if we want to write this as a cosine function, the height that you are on the Ferris wheel at any given time can be expressed by this function. -60 cos power 15x plus 62. And sure enough, if you plug in 15 minutes into that value, you're going to get 122 as your answer, which is the maximum height. So kind of neat things how we can take a situation and model a graph of that. And let's go the other way with it as well. Our final example for this video is on page 531. It says that Ben is a fisherman. He's in a boat in the harbor. And this shows the depth of the water in hours after midnight. So at midnight, it looks like the depth was about 3 meters. The depth increased as the tide came in. So at 4 a.m., it was up at 8 hours. Low tide, it's 2 meters. And the graph continues periodically like that. So a couple things we can do off this. Let's see if we can find the equation of this function. First, let's find the amplitude of the graph. So remember, the amplitude is the difference of the max and the min divided by 2. So the amplitude goes up to 8, it goes down to 2. So the amplitude is going to be 8 minus 2 divided by 2, which is 3. Let's find the period of the function. In order to do the period, we want to figure out how long it takes to do one cycle. So I'm going to see if I can find one cycle on here. And what I like to do is I like to look at it from a maximum to another maximum. So that distance, we go from 16 to 4. So the period is 12 hours, which means that the b value of our function is going to be 2 pi divided by 12, which is pi over 6. So now I got some kind of a cosine function going on here. Let's find the horizontal shift though. If I want to take this part of my graph, my cosine function, what I need to do is I need to shift it. It's basically like a cosine graph that's been shifted 4 to the right. So my c value of my graph is 4. My original cosine graph would be somewhere over here, but I'm going to shift it 4 units to the right. And the horizontal or the vertical change, we could find the average of the maximum and the minimum. So that's going to be 8 plus 2 divided by 2. 10 over 2 is 5. So the function that we want to write then to model this is y equals 3 times the cosine of pi over 6 multiplied by the quantity x minus 4 plus 5. Now we can do a couple things with that. We're asked to calculate the depth of the water at 9:30 a.m. So let's think of where we are at 9:30 a.m. On the graph, it's going to be right around here somewhere. That's right about where we're going to be. It looks like it's going to be more than 2, but what we can do is we know that's 9.5 hours after midnight. So let's graph y equals, we shouldn't even do y equals, you know what we should be doing? It's a function, right? We should be doing like m of t or m of h. Don't write with the eraser. And then we'll make this an h in there. So what we can do is we can substitute 9.5 into our equation and go to our calculator. So m of 9.5, let's go to the calculator and figure that out. Here we go. So we're going to type in, let's make sure we're in radian mode for this calculation. 3 cosine of pi divided by 6 times 9.5 minus 4 plus 5. And we get about 2.10 meters. And the final part of our question says he can only go out fishing when there's at least 4 meters of water in the harbor. And he sleeps until 10. So when can he go out? Well, let's let our calculator figure that out. Because what we're going to do is we're basically going to graph this line and say, okay, after 10 o'clock, I want to know that time of day. So let's graph these two functions on our calculator. So let's add in a graph. Let's graph 3 cosine pi divided by 6 times x minus 4, close parentheses, plus 5. And I'm going to change my window a little bit because we want hours after midnight. So let's go 0 to 24. And let's change our window here from 0 to, I think the maximum depth was 8, so we'll go up to 10 maybe. And I'm also going to graph 4 because I want the depth to be 4. And I want to figure out what is that value after 12 midnight. So let's analyze the graph and find the intersection. Let's go from here to about there, and look what we get. There's our intersection point, so 12.35 hours later. So 12.35 hours afterwards, he can go fishing. Yeah, that's ugly though. Let's multiply 0.35 times 60 to figure out actually what time of day it's going to be. So if I go back here, we do 0.35 times 60, 21 minutes. So he can leave the harbor safely at 12:21 p.m. So this is where Trig gets really neat, when we can actually model some of these functions and write cool trig equations to model periodic data. Oh, doesn't get any better than that, my friends.